Έχουμε λοιπόν την πολλαπλή χαρά και τιμή να καλέσουμε στο βήμα τον καθηγητή κύριο Χριστοφόρου, τον κύριο Ευάγγελο Χριστοφόρου, ο οποίος πολύ γρήγορα σας λέω ότι είναι στο τμήμα μεταλλουργών, μεταλλιολόγους του Εθνικού Πολυτεχνείου, του Εθνικού Μετσόβιου Πολυτεχνείου, και είναι μια καλή στιγμή να δώσουμε το βήμα σε αυτόν τον εξαιρετικό μας φίλο. Κύριε Χριστοφόρου, έχετε λόγο.
Κύριε Κουράκο. Θα μιλήσω στα αγγλικά. Before I start my presentation, I would like to express the sincere thanks of the group of Electronic and Magnetic Materials of the National Technical University of Athens for the opportunity we have to present a part of our work on the so-called Hellenic, which stands, for hybrid electric energy integrated cluster. In this presentation, I will give you some of the most significant outcomes of our work concerning energy production. And when I say energy production, I mean sustainable energy production, which means that our vision is to produce energy, electric energy, with less energy than what we spend to produce it. Critical, difficult, and challenging story. Of course, I have to remind you that electric energy is required not only because traditionally it is used for many reasons. Electric energy is required because the needs of the global needs are increasing day by day and year by year. The problem of this electric energy increase is that the major support, the major raw materials in order to produce electric energy comes from materials which leave their footprint on the earth during the electric energy production. I mean that the CO2 footprint is pretty important and deserves a solution. It doesn't deserve capturing. It deserves solution, meaning that this product with negative value needs some kind of treatment in order to offer positive value product. And in this presentation, my target is to persuade you that we have at least one method to produce sustainably fuels out of water and CO2. It is pointless to mention the CO2 emissions during the last years. Most of you know much better than me the situation concerning the CO2 footprint. Our target is to, our duty actually as a materials group is to develop methods in order to find new families of fuels. And we call these fuels renewable fuels. Why? Because the main source of our raw material is water. And Earth is made of water. We are made of water. And to be honest, we don't quite understand the structure and properties of this material which governs our planet. We do not. This is the reason that up to this moment we are not capable of producing a fuel like hydrogen, which has a thermal power 3.6 times more than the strongest possible kerosene, the strongest possible hydrocarbon fuel. And I call it renewable fuel because in almost all cases, hydrogen is able to produce energy, electric energy or thermal energy, and then it is retransformed back to water. For this very reason, I call water renewable energy, because it offers us fuel and then it is retransformed back to water. How can we do that? Actually, we run a project in Europe doing this activity. We call it Renewable Fuels Project. And for this reason, we collaborate with some institutions in the United Kingdom, in Napoli and Slovakia. The group is rather small, but the results I'm going to, small in number, but the results I'm going to present you, I think are important, and I want your attention to see the energy outcomes out of the process I'm going to present you. I will try to describe the method of producing hydrogen out of the water in very simple words. The state of the art up to this moment concerning production of hydrogen out of water, this means production, thermolysis or hydrolysis of water, is obtained by using platinum catalyst in 850 degrees centigrade. Actually, this result was presented some years ago by Eketa, the Greek research center in Thessaloniki, and the group received the Marie Curie award from the European Union. We do something different. Instead of using platinum catalyst in 800 degrees, we use ferrite. This is magnetite. This means iron 3, oxygen 4, which is a semiconductor in terms of electronic properties, and ferrimagnetic material in terms of magnetic properties. And in order to be able to do that, we have to make our ferrite in nanoporous structure. Nanoporous structure permits a large, effective area that comes neighbor to the water drops dropping on its surface. And what very simply happens is that when the water drops attach the ferrite surface, then the oxygen from the water is captured by the ferrite, and then the ferrite becomes magnemite. This is gamma Fe2O3 oxide, which is a problem. How can we maintain such operation in terms of time, since we have the transformation, the oxidation of the magnetite to magnemite? The answer is magnetic. You can see that the method we produce, we cause the hydrolysis or thermolysis of water is by passing voltage across the ends of the nanoporous ferrite film, and then when water droplets drop on this surface or pass through the nanoporous element, then the oxygen of the water is captured by the ferrite. This means that hydrogen is released. Accordingly, the Fe2O3, which is the oxidized magnetite, has to be transformed into another magnetite phase. How can we obtain that? Simply by passing a magnetic field vertical to the direction of the current. This means that passing current through the nanoporous ferrite, we heat the ferrite. Simultaneously, we produce hydrogen. And by having the magnetic field vertical to the passing current, we generate, due to the Lorentz force, we generate Lorentz electrons, perpendicular to the direction of the field and the current. This means that the electrons go that way. I'm showing with the red point. This means that these electrons do not participate in heating the ferrite, but only in reducing the maghemite back to ferrite. What we have achieved with this is, as you can see, we have achieved a release of hydrogen in as low as 286 centigrade, where the state of the art is currently in the level of 850 centigrade. This result by itself is I mean, we consider it as significant, not only because it drops the hydrolysis temperature down to 286 or let's say 300 centigrade, but also because this temperature permits low energy hydrogen production, low energy thermolysis of water. This means that we are in a position to fight against sustainability of this method of fuel production. But the way we want to use this method is not like the schematic I showed before. The method we wish to make this basic research outcome. An industrial product is to use a porous or microporous element like the catalysts of the cars, made out of ferrite and then passing CO2, carbon dioxide, through these holes simultaneously by passing water droplets in the same time. And then in this catalyst, in this sort of catalyst, we pass current in the X direction and field by permanent magnet in the vertical direction. And what we generate is hydrogen in the presence of carbon dioxide. What we have as a result is the reduction of the carbon dioxide to carbon monoxide and oxygen or hydrocarbon. Different fields, different current offers different level, different type of hydrocarbon, either syngas or methane or propane. The importance of this result is that we operate in below 300 centigrade, allowing for low energy demand of this transformation process. we can use the outcome of this catalyst not only to have hydrogen and hydrocarbon, but also to have separation of hydrogen and oxygen by using electrophoresis methods. This means that if we use electric plates polarized either positively or negatively, we are able to catch hydrogen and oxygen ions, this means cations, protons, and anions of oxygen in the two different plates. Apart from that, we are also able to burn the mixture of hydrogen and oxygen, which actually can come out of the catalyst, in order to generate thermal heat, thermal energy. All these facilities have been realized in the National Technical University of Athens, and these results are subject to publication in the strong international journals, allowing for the possibility of involving the National Technical University of Athens in the new methods of energy productions in the global level. Actually, this is the device we are performing the catalysis, the basic research for the catalysis. And I'm proud to say that we develop also our own nanopore spheroids. We characterize them, we structurally characterize them, we measure their properties, and we also model them by ab initio techniques. So this means that the NTUA, the National Technical University of Athens, is able to develop a mesoscopic scale pilot plant for such either hydrogen production or hydrocarbon production. Apart from that, I wish to show you in just a glance, in just a slide, another method of producing hydrogen out of water. Actually, this is in a very preliminary stage, according to which the laminar water flow passes through a filter, becomes turbulent, and then by implementing simultaneously magnetic and electric fields, we are able to generate, to separate hydrogen and oxygen in room temperature. And bearing in mind that this process doesn't spend the existing magnetic field, because the magnetic field is given by permanent magnets only, we spend only electric field, which is given by, let's say, some source, and therefore we hope that this way we generate hydrogen in room temperature with more sustainable method than the previous method I described to you. Apart from that, apart from the hydrogen production and transformation of CO2, of carbon dioxide to hydrocarbons, we also do other research activities. Do I have some? 5 minutes? Okay, okay. Actually, these things are demonstrated later on at 4:30, I think, in the 4th workshop of this event. And I would like just to mention that we make thermoelectric generators, and we use thermoelectric generators for co-production. This means for production of electric energy and thermal energy. And the results here show that this device promises better results than the photovoltaic cells. We also work in wind generators, in order vertical wind generators in order to be used in domestic applications, and also we try to develop our own rejuvenation process of batteries in order to be used for 15 years instead of 3 years. These results will be also presented, apart from the workshop today, they will also be presented in the conference of Azrael in May 2015. By that time, we will show you, I hope we will show you real products coming out of this laboratory benchmarks. The university is also involved, our group is also involved in electric motion. We make motors, we test them, we also make our own batteries, lithium-ion batteries, and you can see that how a commercial lithium battery looks, and you can see how our homemade lithium-ion batteries look like, and you can see the difference. Those of you who know about structural characterization, you can see the uniformity of the micro-components of our lithium-ion batteries in comparison to the commercial ones. Okay, we characterize them, but we also produce our own fuel cells for several reasons. And I would like to point out that the development of this fuel cell permits the development of our own insulating materials. Insulation is synonymous to energy production because you need less energy if you heat insulate your material. In this picture, I just demonstrate the presence of yttria stabilized zirconia doped with rare earths, which permits a really high insulating process which can be used in buildings. Okay, I don't want to bother you more than that. For further information, we can have a discussion afterwards, or we can discuss and see the experiments in the in our laboratory in Zografou campus. Thank you very much for your attention.
Ευχαριστούμε κύριε καθηγητά. You are always welcome in Azrael.
You mean there is no time for questions?
Is there any question?
Θέλω να ρωτήσω, έχετε και μια πατέντα με μια παρόμοια μέθοδο εξαγωγής υδρογόνου από το νερό με νάτριο, νομίζω.
I forgot to mention that the university owns a patent on this method. The patent, actually, the inventor of the patent, I'm afraid, is not present in this audience. It is Dr. Nick Papadopoulos. Yes, the patent includes also this you are mentioning.
Πώς θα συγκρίνατε τη μέθοδο με το φερίτη και τη μέθοδο με το...
Πάτσε αγγλικά. Ναι.
Πώς θα συγκρίνατε τη μέθοδο παραγωγής υδρογόνου με το φερίτη και τη μέθοδο παραγωγής υδρογόνου με το...
Θα απαντήσω ελληνικά, ναι. Λοιπόν, η μέθοδος παραγωγής υδρογόνου με το φερίτη κοστίζει 286 βαθμούς Κελσίου. Πολύ λιγότερο από τους 850 που το παράγει το ΕΚΕΤΑ και είναι το current state of the art, αλλά παρόλα αυτά 286 βαθμοί Κελσίου στοιχίζουν ενεργειακά. Η παραγωγή υδρογόνου σε θερμοσφαίρα δωματίου με τεχνικές κατάλυσης μόνο από ηλεκτρικό και μαγνητικό πεδίο κοστίζουν μόνο ηλεκτρικό πεδίο. Οπότε απαντώ ότι φυσικά είναι συμφέρουσα η παραγωγή υδρογόνου σε συνθήκες δωματίου. Δεν χρειάζεται να αναφέρω βέβαια ότι τεχνικές όπως είναι η ηλεκτρόλυση κλπ. Έχουν δραματικά μεγάλες ενεργειακές απαιτήσεις και ενώ προσφέρουν πολύ καθαρό υδρογόνο και οξυγόνο, εντούτοις δεν μπορούν να χρησιμοποιηθούν πρακτικά γιατί το κόστος είναι δραματικά μεγάλο. Όχι το κόστος σε χρήμα, το κόστος σε ενέργεια. Με τη μέθοδο αυτή προσπαθούμε να χρησιμοποιήσουμε όσο λιγότερη ενέργεια μπορούμε για να παράξουμε όσο περισσότερη ενέργεια μπορούμε.
Υπάρχει κάποια άλλη ερώτηση?